Hi and welcome to another video from TOGAtech. My name's Dave. I don't know if you've ever watched any of my previous videos. You can see I'm slightly obsessed with flight sim button boxes. I've built the general aviation one here and the A320. This is based on the Airbus A320 and also the G1000 autopilot panel here as well. Now I'll leave a link to all of these builds in the description below, but what I've got now is I'm now using the Oculus Quest virtual reality headset, and so I need to be able to produce a button box that I can operate just using touch, because obviously with the headset on can't see where the buttons are, and I want again to bring it down to just primary functions on the autopilot, also lights, master battery, fuel pump switches, etc. So I want basic functions on a small box, small button box that's relatively cheap to build, using cheap products, and hopefully using a Arduino Leonardo as well, which will also reduce the costs. So hope you enjoy this video. Let's get into it, and we'll start off with the design. Right, using a FreeCAD, which is a free software, I'll leave a link to their webpage in the description. I designed the fascia for this virtual reality button box. It's very simple. I based it roughly on the same size as my Cytec X52 HOTAS system, so it's 170mm by 170mm square. It's approximately 4mm thick, has 4 mounting holes, 20 holes which are 14mm square for the Cherry MX buttons, and 4 5mm or 6mm diameter holes for the Rotary encoders. It was quite easy to produce on FreeCAD. Once I've done that, I exported it as an STL mesh, imported it into Cura from Ultimaker. This fit nicely on the bed, and printed it off. Okay, for this project you're going to need 20 MX Cherry switches, 2 potentiometers, 4 KY04 rotary encoders, an Arduino Leonardo, some dew point cables, and a variety of coloured multi-stranded copper cable, and of course your assembly panel, like so. Okay, let's get on with wiring it all together. Right, so here we have our mounting panel, my top panel for our VR button box. But before I add the switches in and the rotary encoders, I want to cover this in a covering, which is this here. It's a carbon fibre look-alike self-adhesive covering. You can find it on various suppliers. So let's give that a little cover, give an idea of the size we need. Like that. We also want to wrap it around a bit. So there, and say there. Right, cut that piece off. And then if we take what are our MX cherries, should be able to push those in. Now try and keep them all the same way round because it will make it easier for wiring. Now that's the top, because my rotaries are going on the bottom, so that's the top. So I'm going to keep my pins facing downwards, so all the switches are always facing the same way. That should just pop in there, like that. Get our first button in. Just to work our way along now, get them all in. So here we are, we've got a 5x4 button matrix, but I've also got a button on the rotary encoder, so that makes a 6x4 button matrix. So what we have to do is we have to wire in turn between each one of these terminals down to produce a column. These are columns running from top to bottom, and these are the rows running from left to right. We need to link all these pins here, including, so there's 1, 2, 3, 4, 5 pins there, plus one pin for the rotary encoder, and that will make one column. And then we'll do the same for each column. It'll make more sense as you watch me go through doing the wiring. So let's get set up with the soldering iron and some link cables. Now I recommend using various coloured cables. This little handy little unit here, if I can find a link I'll leave it in the description below, but it gives you all different colour wires, and I'm going to use a specific colour wire for my columns and a different colour wire for my rows. So when I come to wire them to the Arduino, I'll know what I'm doing. If we refer to my wiring diagram, you can see which colour I'm using for the columns and which colour I'm using for the rows. Okay, let's get the soldering iron set up and we'll get on with soldering these up together. Okay, I was trying to find the easiest method of doing this. I've looked back, if you check on the wiring diagram, which again I'll leave a link to, I'm using yellow cables for my rows and blue cables for my columns. So I've made up, I was trying to work out the easiest way of doing this, so I've made up this little chain here, little links here, and what I'm going to do is I'm going to tin the end of these wires so make them solder into the switches a lot easier. You've got to be careful with these switches because they're only little switches inside plastic. If you get them too hot, you'll melt the plastic and they'll be no good. So dab a little bit of flux on these and tin these wires up first before I try and attach them to the switches. What I'll do is I'll do one row and one column on camera, and then I'll probably just do the rest off because it's very tedious. This is the tedious part of the project, the worst part of the project, but Again, it will save you an awful lot of money. The other thing you can do is get a PCB made up, which I might look at after as well. You might be able to make up a PCB. So be careful with your plastic. It's nice hot soldering iron. Let's get some solder on these wires. Tin them up with solder first. It makes it easier to solder to the switches. You don't have to apply so much heat to the switches. Nice little helping hands would help. Haven't got any. Then use some wire with some crocodile clips. A little bit of solder on there first. Attaching to the switches a lot easier. Again, you don't have to use MX switches, you could use any type of momentary switch. I just had a lot of these lying around, so I thought I'll make use of them. Okay, right, let's try and attach this to our first button. So our columns is the pin, if you're using the MX switches, the pin on the right hand side I'm using as my columns, the pin on the left hand side I'm using as my rows. So we're going to attach all the left hand pins together. So a nice bit of solder on there, and let's attach the first one. Might have a bit of Blue Peter shaky hands here. See. Don't want to apply it for too long because it will melt the switch. Just hold it there until it cools. And it's got to hang on there. Look. There you go, that's got a grip on there. Try the second one. Attached to there, a bit more solder. Try the third one. As that solder starts to run, remove it so you don't melt the switch. And the last one to go on. Let's try to get that in place. Just hold it there till the solder cools. There we go. And you see this fly lead here, you can see that, that's going to go off to our Arduino. So we've got them looped pin to pin to pin to pin off to the fly lead to our Arduino. So that's our first row done, and then we'll do a column same way, so this will be coming down this way, and obviously leaving an extra connection, don't forget, for our rotary encoder, which isn't present at the moment. Let's do one column and then I'll do the rest off camera. So we're going to do our columns in blue. So what I'm going to do is to slip off a few lengths of blue cable. You don't want them over long, but you want to be able to curl them like that, and obviously take the insulation off the end. So we want 1, 2, 3, 4, 5 little links. 2, 3, 4, 5, and then obviously a fly lead that goes to the Arduino, which has to be a bit longer. There's our fly lead. Nice pair of wire strippers. Strip those ends off. Seemed to work quite well, this method on that one, so we'll repeat this. So there are our little link cables. What I do is twist them together before I solder them. There we go. You see this one here, this point here, that's for connection to our rotary encoder, which will go on the... You've got two terminals on this rotary encoder, don't know if you can see them. No, come on you. Well, there's two terminals, one's marked SW and one's marked plus, positive. You want the rows to go to the plus and the columns go to the SW. So this is a column, so that would connect to the SW pin on your rotary encoder. There. Now what I'm going to do, I'm not going to solder these direct, I'm going to connect to that a DuPont lead. One in blue. Pull off a blue DuPont lead. Separate that for a second. So I'm going to use this blue DuPont lead because that's going to connect to the SW on my rotary encoder, which is there. Connect on there. Solder that to there. So let's just quickly do that. Cut that end off. That concludes our first column. So we've got a link to our rotary encoder and then our fly lead to our Arduino. Okay, I'm going to work my way through off camera doing all of these because it's very boring for you, and I'll come back to you when I'm done. Okay, see you in a second. Okay, well, welcome back, and here you can see I've wired up our button matrix and our rotary encoders. I've tried to stick to wire colour coding as best as possible. We've got our rows in yellow which go from button to button to button to button, and then a fly lead off which will connect to a pin on our Arduino. We've got 6 rows, 1, 2, 3, 4, 5, and obviously the button on the rotary encoder, 6. And then for our columns, which we've got 4 columns in this matrix, I've used blue, and these are all our tail ends for our column connections. These will go to the Arduino. And then the other wiring we've got here, we've got our data, our DT and a CLK from our rotary encoders. These are separate cables here that will go to our inputs on the Arduino. There's 4 of those for the 4 rotary encoders, and then we've got a common ground to all 4 rotary encoders. That's one common ground there, and that completes the fascia panel. Just flip that over now. So here we've got all our cherry switches wired up. That's 1, 2, 3, 4, 5 rows of cherry switches by 4, so it gives us 20 buttons on there. Then we've also got another 4 buttons here on the rotary encoders, and then the 4 rotary encoders themselves. The only other thing we've got on top of that is we'll have 2 potentiometers. These I'll be using for my throttle mixture and for my propeller pitch. So these are analog devices, so you need 2 of those, and they'll be wired to the case of this box. Again, they just have 3 wires. They have a 5V in, a ground, and they have a sweeper, which is the data cable, the analog signal that goes out. We've got 2 of those, and then we'll wire those to the Arduino as well. Right, so that's it for the wiring and the construction of the front of the box. The next thing we've got to move on to is the coding of the Arduino. So let's take a look at that. Okay, what you're going to need for this is Arduino IDE, which is a piece of software. It's a free piece of software you can download. So just Google search or whatever other search engines you use, type in Arduino IDE, download and install this piece of software. The 2 other things you're going to need to download, I'll leave a link in the description below, there are 2 library files, which is keypad.h and joystick.h. Now these libraries are pre-written pieces of software that you need to control your button inputs and your rotary encoder inputs. I'll leave a link in the description for where you can download them. And the third thing you need to download is another sketch, an Arduino sketch, which was written by a guy who I'll leave details of his software and everything in the description. And it's a sketch called, if we go up here, we go File, Open. It's this here, WIM_S_button_box_code. Now this is the basis of your button matrix and your joystick controller. Here you can see these are the 2 libraries that you need to install as well, which I'll leave links to everything in the description. Alright, so we're going to open up this pre-written piece of software. And here you can see it's opened up here. Now it's including these 2 libraries. The first line here, if you've never used Arduino IDE, I recommend you go online on YouTube, and there's lots of people explaining how it works and how you can write software yourself to do various functions with these Arduinos. But I'm not going to go into great detail. This guy's already written this piece of software, which is fantastic. All we need to do is to change the question marks to the number of buttons and rows we have, the number of rotary encoders we have, the number of potentiometers, and their pin locations on the board. So if you use the Fritzing wiring diagram that I've left a link to, you can see where each component connects to the Arduino board. This will make more sense as we go along. So if we work our way through the software, it says include keypad.h, which is a pre-programmed library, include joystick.h, which again is a pre-programmed piece of software, and then we'll read through the definitions here. Number of rotaries. Now it's got a question mark because it's asking you how many number of rotaries you've got. So all you need to do is to change that question mark to the number of rotaries you're using. I'm using 4, so I'm going to change that to 4. Number of buttons. Replace the question mark with the number of buttons you're using. I'm using here, it's actually 1, 2, 3, 4, 5 rows of 4, which is 20, but the rotary encoders each have a button on them as well, so that'd be 24 buttons. The number of rows in my button matrix, I have 1, 2, 3, 4, 5 plus the rotary encoder row, that's 6 rows. And the number of columns, I have 4 columns. Now the next line here, first change the number of rows and columns to match your button matrix, which we have up here. Then replace all the question marks with the numbers starting from 0. Now this is the number of buttons we've got, so we've got 24 buttons. The first one starts with 0, so we've got 0, 1, 2, 3. That's our first row. Our second row will be 4, 5, 6, 7. Our third row will be 8, 9, 10 and 11. Our fourth row will be 12, 13, 14, 15. Now we need 1, 2, 3, 4 rows. We need 6 rows. So I'm just going to copy this statement and then paste it here. Paste. That's 1, 2, 3, 4, 5. I'm going to paste one more. Paste. Okay, now at the end of each row there should be a comma, except for the last one, comma. So that's up to 15 there. So this one here is going to be 16, 17, 18, 19, 19, that's going to be 20, 21, 22, 23. Now we've got 24 buttons, but don't forget we started from 0, so that will end on 23, and that's that bit. Now we go down to the next bit, rotary encoders. Now each line controls a different rotary encoder. The first 2 numbers refer to the pins the encoder is connected to. So you need to refer to your wiring diagram. So my first rotary encoder is connected to, if I look at the pins, is connected to pin 0 and 1. Then my second one is connected to 2 and 3, my third one 4 and 5, and my fourth one 6 and 7. So this matches exactly what I have here, and I have only 4 rotary encoders. If you're using less, delete a line. If you're using more, you can add another one in. But you must not exceed 31 for the final button number. So you can see this final button number is 29, and it works backwards that way. Now we're using, if you can see up here, buttons 22 and 23 are on my matrix, but they also clash with buttons 22 and 23 on my rotary encoder. So I'm now going to change this so that my last rotary encoder starts at 31. So it'll be 31, 30, 29, 28, 27, 26, 25 and 24. There you are. So there's no clash now because my button matrix ends at button 23 and then my first rotary encoder starts at button 24 up to a maximum of 31. You cannot exceed 31. So that's the most I can get on this Arduino Leonardo. So that's that one. Let's work our way down the software again. Now I'm just going to run through the tools. I'm going to check, going to verify and compile just to make sure there's no errors. And it's got an error come up. But that's down here, we haven't got to that part yet, so that's fine. Right, let's carry on down here. Right, button matrix part 2, number of rows, number of columns. Now we need to change here to the number, change the question mark to the pins of the rows that the button matrix are connected to, and here the pins, the rows that the, well, that should say columns of your matrix are connected to. So number of rows. Now my pins on my rows are pins 8, 9, 10, 11, 12 and 13. If you're copying mine, you can just copy this. If not, refer to your own diagram. So it's pin 8, pin 9, pin 10. Now if I need more, I have to add in, don't forget to put the comma in, 11, 12 and 13. So it's 8, 9, 10, 11, 12 and 13. They are my 6 rows. And then my column pins here, they are on A3, A2, A1 and A0. A0, A1, A2, A3. And that's my column pins. Right, just going to check that, verify and compile again, see if we've got any errors. We've got some errors further down here, this section here on the joystick. Joystick does not name a type of joystick, so we'll move on to this. This is where we're setting up our potentiometers here. So I need 2 axes for my potentiometers because I'm going to be using them for mixture control and propeller pitch. All you have to do is change the axes here to true for whichever ones you want to use. So say I'm going to use my RX axes, I'll change that to, well, it's using Z axis and RX axis, so I'm going to use the same there. So Z axis I'm going to mark as true because we've got 2 potentiometers. I'm going to have that as true. and the other one, as you can see down here, Z-axis and RX-axis. So we go to RX-axis and we'll make that one true. That's our two potentiometers. Add all the axes which are enabled above. So we've got Z axes and RX axes, which is right, they're the two. If you were going to use a third one, then you'd have to add that integer here. Potentiometers part 2. Which pins are the potentiometers connected to? Well, they have to be connected to an analog, and the only two analog ones I've got left are on A5 and A4. A4, A5. So it's those. Nothing for me to change the details to match details of your potentiometers you are using. See, it's on the Z-axis, so that's fine, and on the RX. This is if you had a third one, you'd have to copy this code in and change the axis value to RY or whichever one you're using. And I believe that is it. So let's just go through the verify and compile again. Now it does have a problem here with the type of joystick. Cannot find this Arduino library. So I'm going to save the file at the moment where it is. I'll save it as a different name. Save as. I'll call this 24 button box. I'll just save it as that so it doesn't overwrite the initial coding. Now we have to sort out this error here. It's not finding this type of joystick. Right, it appears I seem to have worked out the problem. It's this library here, joystick.h library. Now what's happened is I have a number of joystick libraries in my Arduino file. They're all got the same name, even though they're completely different sets of programs. They all have the same name of joystick.h. So in order to get round that error code that you saw there, I had to delete all the libraries marked joystick and then reinstall the correct one I needed, which was from a guy called, I don't know if I can pronounce his surname correctly, it's M. Hieronymus Arduino Joystick Library, but I'll leave a link in the description below as to where you can download his joystick library, and that's the one you need for this system. But as you can see now, I've changed all the question marks to what I need, so number of rotaries 4, buttons 24, rows, columns, etc. Replaced all the question marks with the correct data, including the pin assignments, and you can get all that information from the PDF file which you can download. And now if we just go into this and check the sketch by verify and compile, it's run through the sketch there, no errors, it's all done. That's great. So I'm just going to save that file again, and then you need to upload it to your Arduino. So let me see if I can show you how to do this. Now we've got our sketch done. We've done an integrity check on it, and that's all okay. It's come back compiled and verified. So now all we have to do is upload it to our Arduino. So we've got our Arduino here, Arduino Leonardo. We've got a USB cable connected to the PC. So if you just go up here to Tools, check that you're on. So we're connected to our PC, Arduino Leonardo. And COM port, we're on COM port 5. Yep. Get board info. There it is, that's our info. Happy with that. Upload sketch. And there's all our lights flashing there. Boom. That's our sketch loaded. So now that piece of programming is hardwired on that chip. So the next stage now is to connect all our buttons and wires to the relevant pins on the chip and test it out. Let's go for it. Welcome back. We've completed the coding on the Arduino, and as you can see, here's the finished box with all our switches. I printed off 3D printed some rotary encoder knobs to go on our rotary encoder. We've got it connected to our micro USB cable. So the next thing to do is to plug it into our PC and just test it out on the game controller software that's built into Windows. So let's bring that up and we'll see if that's functioning. So if we go onto here and type in game controller, and it will come up set up USB game controllers. And if you can see that, let's bring that over, you can see it's already showing Arduino Leonardo there because it's detected that controller. So if we click on that, I want to try and get this so that you can actually see the button box at the same time. So let me just reposition the camera for a second so that you can see the button box, which is there. Here it is here, and at the same time you can see up here. So we go into game controller Arduino Leonardo, click on properties, and here it is. It's come up with a testing screen. Now if you watch the test screen, as I press the buttons, you'll see that's button 3's come up, button 4, button 1, button 2. They seem to be in a random sort of system, but I think that's to do with the matrix. So on there's button 7, button 8, that's 5. It makes no difference for when that's 6 when you probe them into your game. 11, 12, 9, 10. So you can see all the buttons are working on our matrix. And then these are your rotary encoders here. You can see those are going. That's 31 and 32. This one 29 and 30, and this one here is 20, 27 and 28. And this one, unfortunately, this rotary encoder does not work. But what I recommend doing is testing your encoders before you fix them into your system. But I'll get that one working. And also I had problems with getting the button function to work on these rotary encoders. But that's down to my rotary encoders. These I have pulled out of another project and reused, so that could be the reason why this one's not functioning. But all the button matrix is working. 3 out of the 4 rotary encoders are working. And also on the side here I have my Z-axis and X-axis that I'm using for propeller pitch and mixture. You can see those are functioning there and there. The only thing to do next is to put this in game and get it working in game. Well, there you have it, a fully functioning 24 button box with 4 rotary encoders, 2 potentiometers, all running off an Arduino Leonardo, and the cost of this compared to the products you purchase is minimal, absolutely minimal. In fact, I built this from all the parts that I already had in my shop, so there was no cost involved for me whatsoever. Again, hope you've enjoyed the video. Don't forget to like and subscribe. If you have any questions, drop me a comment, and I'll see you next time on TOGAtech.